With each new and captivating image, the James Webb Space Telescope continues to receive hits from all around the cosmos and even from planets in our solar system. A year ago, we were treated to our first taste, and the images, the Carina Nebula, Stephan's Quintet, and most dramatically, this so-called deep field image that appears to depict dozens of galaxies extending into the far reaches of the universe, did not let us down. The James Webb Space Telescope has recently discovered objects that completely disprove existing cosmological ideas. Hence, they are being dubbed universe breakers by astronomers. The reason for this remains a mystery, thereby rendering all of our predictions and hypotheses incorrect. So, what's new with the James Webb Telescope? What did it find out that we didn't know before? Join us as we explore how the James Webb Telescope found evidence of another universe that upends the Big Bang.
Enter Webb's first deep field, centered on the galaxy cluster, SMACS 0723, a cosmic neighborhood harboring an ensemble of thousands of galaxies, some of which are the most subtle sightings ever captured in the infrared. Think of this image as a cosmic speck, similar to holding a grain of sand at arm's length. It represents just a fraction of the expansive universe. SMACS 0723, acting as a gravitational magnifying lens due to its huge mass, not only showcases galaxies within the cluster but also amplifies more distant ones, some dating back to when the universe was less than 1 billion years old. Webb's near-infrared camera crafted this deep field image, compiling images taken at various wavelengths over 12.5 hours. A feat surpassing the depths of Hubble's deepest fields achieved over weeks. Yet, this is only the initial part of the revelation. The telescope's continued use extended exposures, peeling back more layers of the vast cosmic canvas. Transported 4.6 billion years into the past, this image illuminates the galaxy cluster, SMACS 0723, unveiling several galaxies stretching both before and beyond the cluster's borders. Delving deeper into Webb's treasure trove of data will undoubtedly unveil further revelations about this cosmic cluster. Webb's mid-infrared instrument also contributed to this field snapshot, casting its eye on the mid-infrared spectrum. What's truly groundbreaking here is Webb's NIRCam's precision in focusing on these distant galaxies, revealing intricately faint structures that were once hidden, featuring star clusters and ethereal diffuse elements, a whole new vista previously unseen in our exploration of the cosmos. When the James Webb Space Telescope unveiled the cosmos, it was a brand new revelation. Almost immediately, incredibly distant and glaringly bright galaxies leaped into view, catching astronomers off guard. These galaxies, seemingly from the universe's earliest times, showed up much sooner than anticipated, suggesting they formed ages before anyone thought possible. This was a concept that was almost impossible to grasp because it meant that some galaxies had formed just 330 million years after the Big Bang, setting a new cosmic record. Even though one of these galaxies was quite dim, others from the same period were blazing bright, hinting at their potential enormity. This sudden appearance of massive, luminous galaxies at such an early cosmic stage left scientists scratching their heads. It was a puzzle they weren't expecting because the surprising discovery contradicted what was known about the formation of celestial bodies so soon after the universe's birth. The prevailing belief was that significant cosmic structures take eons to evolve. But these early galaxies were rewriting that rulebook, prompting some to question the fundamentals of our understanding of the universe. At first, there was excitement that these revelations might shatter the tried and tested Lambda CDM model, the backbone of cosmology. There were whispers of new cosmic elements or laws governing the universe. It became evident that the JWST findings were revolutionary, and they sparked a reevaluation of how galaxies are birthed, especially during the universe's dawn. Astronomers are now reconsidering the very beginnings of galactic formation. The James Webb Space Telescope has been brewing for quite some time. The roots of its revolutionary observations stretch back to 1985 when it was involved with the Space Telescope Science Institute. While the Hubble Space Telescope was prepping for launch, Riccardo Giacconi, the Institute's director at the time, nudged Garth Illingworth to envision what would come after the Hubble. This paved the way for the next-generation space telescope, which later became known as the JWST. Hubble was a game-changer, but it had limitations, as it mainly worked in visible light. In a spectacular image, Webb captured WR-124, a star teetering on the edge of its grand explosive exit as it's set to go supernova. The image grabs the star right before its supernova show, which is the final moment of a star's life cycle. That's when it unleashes a colossal cloud of scorching gas and interstellar dust into the great beyond. What's unique here is that Webb snapped this massive star during its Wolf-Rayet phase, right before the supernova, when it was shedding its outer layers. The telescope's mega instruments zoomed in with amazing detail, offering astronomers a seriously rare jackpot view. But why is this cosmic dust so vital? Because it's like a time capsule for astronomers, holding clues about the universe's early days. NASA calls dust crucial in the universe's history, nurturing star formation, clumping up to craft planets, and ultimately cooking up the ingredients for life on Earth. But here's the grand mystery. There's more dust floating around than we can account for. By looking at these types of images, astronomers aim to see if dust grains can survive supernova events, which might explain this puzzling dust surplus. When Webb dropped the next image, it was chaos. In a tiny corner of that snapshot, researchers stumbled upon a discovery that was about to give our understanding of the early universe a whole new meaning. A closer look at the data revealed what seems like 6 ancient galaxies, existing when the universe was just 3% of its current age, 500 million to 700 million years after the Big Bang. These galaxies, way larger and more developed than expected, are what's causing a stir at the moment. Joel Leja from Penn State shook the cosmic paradigm by suggesting that galaxy formation kicked off way earlier than we thought. These galaxies are now becoming known as the universe breakers. Then came Pandora's cluster, a brand new chapter in cosmic revelations. In this deep dive into space, Webb unveiled Pandora's cluster, a spectacle of 3 colossal galaxy clusters merging into a megacluster. The gravitational lens created by their combined mass gives us a clear view of other galaxies. Ivo Labe from Swinburne University was awestruck, calling Pandora's cluster a lensing powerhouse unlike anything seen before. The image was so stunning that it looked like a simulation, serving as a reminder that we were navigating uncharted astronomical territory. Webb's exploration doesn't stop there, though. It ventured into the cosmic tarantula, uncovering thousands of brand new young stars in 30 Doradus, fondly known as the Tarantula Nebula for its spidery dust filaments. This gargantuan stellar nursery not only illuminated the nebula's composition, but also revealed protostars, infant stars still gathering mass. It's a peek into the future, hinting at how these protostars will shape and mold the nebula over time. See, in the story that the astronomers believed to be true, massive galaxies weren't supposed to show up early in the universe. They hadn't had enough time to form stars or even collide together. It was like finding a surprise ending that nobody saw coming. Computer simulations of lambda CDM-based universes didn't line up either. JWST's bright galaxies were like heavyweight champs compared to their simulated counterparts. Now, most people claimed JWST was flipping the script on cosmology, but not everyone bought into the hype because the predictions from lambda CDM are often fuzzy. Dark matter and dark energy are straightforward, but visible matter behaves in mysterious ways, and no one fully knows what went down in the beginnings of the universe. Plus, figuring out a galaxy's exact distance is super tricky. Since JWST's first discoveries, some high redshift galaxy ages got a recheck. Turns out they might not be as distant as initially thought due to updated telescope settings. Take Sears 1749, nestled in a galaxy cluster whose light dates back 12.4 billion years. This might just be a closer cosmic neighbor putting on a redshifted disguise. Naidu thinks this galaxy could be a whole new cosmic oddity, a tiny dust-filled body challenging what we know about distant galaxies. As people across the globe marveled at the mind-blowing images sent back by the JWST, a behind-the-scenes quest began. Scientists dived into deciphering whether these newly discovered galaxies were cosmic rule breakers or simply fine-tuning the already established equations in lambda CDM. Up till now, things were mostly based on speculation. However, scientists are always out to find the real truth, and they aren't going to rest without it. One of the cosmic puzzles that's been keeping them busy involves figuring out the masses of these ancient galaxies. Megan Donahue, an astrophysicist at Michigan State University, explained how determining a galaxy's mass boils down to its brightness. However, linking brightness to mass isn't a straightforward affair. It's more of an educated guess based on assumptions drawn from stars we know and galaxies we've thoroughly studied. The key player in this guessing game is called the initial mass function. This IMF essentially helps in calculating a galaxy's mass from its brightness. But what if this IMF was different back in the early universe? If so, the JWST's ancient galaxies might seem super bright but surprisingly lightweight. Tinkering with this fundamental piece in the lambda CDM puzzle could give us answers all across the cosmic spectrum. Some astronomers see this as delving into the cosmic rabbit hole. NASA, fresh from JWST's triumph, has unleashed ambitious plans. They've kickstarted their modern-day Apollo era with Artemis I's lunar mission, and even started constructing a Martian drop-off hub akin to Star Trek. At the American Astronomical Society's 241st meeting, NASA teased their future plans, heralding a revival for American space exploration. Among the spotlighted announcements, what's really stealing the limelight is the Habitable Worlds Observatory. This telescope is almost like a space detective, designed to scan the cosmos, decoding an array of cosmic light, and stationed right beside its sibling JWST. Its grand mission is to seek out extraterrestrial life. Envisioned from the 2021 Decadal Survey, the HWO will be about 20 feet tall, with capabilities spanning ultraviolet, visible, and near-infrared wavelengths. These wavelengths are the cosmic eyes of Hubble and JWST. The estimated cost for this celestial sleuth is $11 billion, $1 billion more than JWST's price tag. Positioned at the second Lagrange point, L2, like JWST, this gravitational haven shields it from the sun's glare. What sets it apart is its potential servicing ability, making it upgradable even amidst the vastness of space, unlike JWST, which lacks this option. The Hubble Space Telescope, renowned for its human-assisted repairs, was hailed as the People's Telescope. In contrast, the HWO, with its serviceability and enhanced capabilities, aims to unlock mysteries of potentially habitable exoplanets. Do you think that the JWST will eventually debunk existing cosmological models? Let us know in the comments, and for more videos like this one.